NFDI Talk. This episode's title is Knowledge Graph Kitchen, an integrated ETL environment for decentralized research data integration. Today's speakers are Professor Dr. Harald Sack and Professor Torsten Schrade. Since 2016, Harald Sack has been a professor of information service engineering at the Institute for Applied Informatics and Formal Description Methods at the Karlsruhe Institute of Technology. He's also head of information service engineering at FIZ Karlsruhe, Leibniz Institute for Information Infrastructure. Since 2019, he has served as co-spokesperson of NFDI for Culture. Our second speaker, Torsten Schrade, has been head of the Digital Academy at the Academy of Science and Literature Mainz since 2009 and Professor of Digital Humanities at Mainz University of Applied Sciences since 2017. Since 2019, he has served as spokesperson for NFDI for Culture and since 2021 as a member of the Scientific Senate of NFDI. So welcome Harald Sack and Torsten Schrade. I will now hand over to you two.
Thank you very much. My name is Harald Sack.
And my name is Torsten Schrade.
And together we are both part of NFDI for Culture. And today we are going to talk to you about the Knowledge Graph Kitchen and of course how to cook with it. So it's all about knowledge graph-based research data management, and we are introducing to you also an integrated ETL environment for decentralized research data integration today. Okay, so what are we going to talk about? Sorry, that was already too early. No, not too early. Considering the motto of our talk, of course, we had the assumption right in the beginning of the project that, of course, all NFDI consortia share similar pain points and kinds of problems. And of course, we are looking for comparable solutions. So all have kind of organizations that are involved, people are involved, tools are involved, workflows, data, and so on. And our solution provides here or seeks to provide knowledge graphs. And what we are going to talk about today is the ETL pipeline, which is focused on harvesting data, processing data, mapping the data, integrating it within the knowledge graph, and then, of course, also to enable search and discovery on the knowledge graph. And how are we going to proceed? So first, we give you a brief introduction into the data we are dealing with, so the NFDI for Culture data domain, followed by an introduction into our knowledge graph, and of course, then the main part, the knowledge graph kitchen. And all these things, they are based on a core ontology, the NFDI core ontology and its module extensions, and which will be then one of the last parts of the talk. And then, of course, in the end, we will have a look into the future. So we are looking at the road ahead, at accessibility and network effects. And now we are going to start with the NFDI for Culture data domain and the problem of truly linked research data. Torsten.
Thank you. And as you see in the kitchen, it's always between the members of the kitchen. So we switch very rapidly in our little kitchen talk here today. So I have the pleasure to introduce you to the NFDI for Culture domain, which in the landscape we are dealing with is quite a multitude of actors. So in NFDI for Culture, we comprise several disciplines: architecture, artistry, musicology, media studies, performing arts. So that's the research part, but also GLAM institutions. GLAMs, that stands for galleries, libraries, archives, museums, but also the design and creative sector. So it's quite a very diverse landscape. And of course, it has very, very diverse data. Where does our data come from? So basically, from a research perspective, it comes from architecture, artistry, musicology, performing arts, and media studies, but you will have very many different data types, non-textual data types, something like a 3D model, for instance, in architecture, or a huge amount of pictures from paintings in art history, or for something completely different, notated music and musical sheets in musicology, or stage performances in performing arts, which is a complex data type because it's always time-bound. And of course, the media studies and also film heritage, you have video-based and audio-based data types that we try to integrate together in the cultural knowledge graph. So that means for us, a great challenge in NFDI for culture is that this research landscape provides a huge amount of data, but it's absolutely widespread. It's decentral. So still today, we've counted more than 70 data portals, and we have a rough estimate that in those data portals, and you just see a glimpse of them right here on this slide, there are roughly about 100 million data items. And since the digitization campaigns, especially in the CLAM institutions, go on, we expect that this amount of data items will triple in the years to come. So that's quite a huge challenge. The next challenge that we have to tackle if we want to integrate all that research data in our domain is that it has very many different levels of structured information. So from the last slide, many of the data you will just find on simple, in quotation marks, websites without any API, without any structured data. And we need solutions for this. In other cases, which also is very common, you have structured data. It's also mainly data portals that provide data for different of our research disciplines. But sometimes, or very often, there are no APIs, no dedicated way of getting to the data. And of course, in some cases, you have 5-star LOD and Sparkle endpoints where you can retrieve the data from. So, and we have to cater with a tool chain for all those scenarios. And what do we have to do with this data? Just a quick example. And in the beginning of the project, I got a very nice question from Harald. Are there any dragons in the NFDI for Culture research data? Now, a few years later, we can say, yes, definitely. There are lots of dragons in here, small dragons from medieval stained glass on the left side, large dragons in Baroque ceiling painting. You also have singing dragons in music and notated music. And of course, you also have performing dragons, like this very nice puppet marionette from which we have several images. And all this comes together, for instance, in one of the major authority systems in our domain. This is iconclass, and in iconclass you have a certain code for a certain iconography. So that's a very important connection point for us that we for data integration into the cultural knowledge graph. Yes, and so this is why we've chosen this knowledge graph-based RDM approach in NFDI for culture. And in the beginning of the project, we realized that it makes much sense to divide that knowledge graph-based approach into two separate sections: the research information graph and the research data graph. And what this is all about will be told to you by Harald.
Okay. Thank you. So now let's talk about the NFDI for Culture knowledge graph, which actually are two graphs, as we have already heard. So we have on the one hand side the so-called research information graph, which covers all kind of information that is related to a specific consortium, its organization and administrational things. And on the other end, we have the research data graph. This is the way then to the actual data, but it's not the actual data, it's an index over the data. Because the knowledge graph, as we have seen 2 slides back here, I will switch on here my pointer. The knowledge graph simply serves as a centralized index that tries to integrate all of the different heterogeneous resources that we have here in the NFDI for data landscape. So let's have first a look at the NFDI for Culture research information graph. As I told you, it's an index and metadata for culture project resources, like, for example, all of the persons that participate somehow in the project, all of the institutions, the expertise of those persons, who should I ask for which kind of repository if I have a problem there. Then, of course, what are the data resources we are talking about? What are the data services? And the main purpose of this information, it serves as a backend and a data resource for the NFDI for Culture portal, which is basically our web page. So the web pages, if you go to nfdiforculture.de, this in the end takes into account, or it's created from the data that is in the knowledge graph. So the NFDI for Culture portal as an information system provides a unified and intuitive access point to the decentralized research data that we have here in the NFDI for Culture research community. And it's organized twofold. So, for example, for all of the entities that are part of the knowledge graph, you have here, for example, HTML renderings of these semantic entities. And on the backend side, what you also can see, you have here a content management system. So here it's typo 3, and this is based on a CRIS extension, which of course serves as a metadata schema for all of the projects, persons, publications, and the stuff that is represented in there, in, of course, combination with an underlying ontology that I will talk about in a few minutes. And this serves as a backend in connection to a triple store, which then in the end provides the data that you can see on the pages, the web pages of NFDI for Culture. But more interesting is the research data graph. So this graph contains metadata and metadata index for the content of all of these repositories that you have already seen. And as I've already told you, they are in heterogeneous states. So on the one hand side, we might have already fully fledged linked open data, research data resources, like for example, there is a Sparkle endpoint. On the other end, there are APIs provided, like for example, with standard metadata, OAI PMH, like in the libraries, Lido, like in the museums, or CDOC CRM, for example, which are rather prominent formats in our domain. And on the other hand, you might have web-based legacy data. So that means that things are available somehow on the web, but of course, they don't provide a dedicated API. And for that, we have developed a method which is called ZGIF harvesting, which will be then later on explained by Torsten. And of course, there are several other resources which are not fully fledged linked open data resources in terms that there is an underlying ontology. Like, for example, if we have Wikibase-based resources, and also for them, we have created a way to map them and to also incorporate them into our research data graph. And in the end, you see then here single resources on the instance level and all of their connections within that index. And we provide, as we will later show you then, ways to explore and to search this knowledge graph.
Yes, and to come to this knowledge graph, we realized that we need a tool chain with which we can cook up this knowledge graph. And since we have quite some culinary approaches in NFDI for Culture, we called it the NFDI for Culture Knowledge Graph Kitchen. And I'm going to present you some aspects of it. So what Harald has just shown you has the following workflow in the back end. So on a sort of macro perspective, a data provider first contacts the Culture Information Portal. And you can see this on that #1 contact screen here. And then we speak with each other, and this will lead to an analysis of what data formats, just as Harald has explained, a data provider can provide to the knowledge graph. And this will be provided in several ways. And our kitchen has, of course, to adapt to any kind of data provision in any kind of format. And this is done via the Culture Knowledge Graph extract, transform, load pipeline, which I'm going to show you in a minute. Depending on what format we have, we go about and harvest the data, which will then be aligned and stored in that central metadata index, which in the end comes together as the Culture Knowledge Graph. Here we go. Now we go to the Knowledge Graph Kitchen. So as you can see, this is just one part of a 6-step process. What were the goals of or what are the main goals of the ETL pipeline? For once, we always wanted it to be designed for efficient harvesting and processing of that many decentralized data feeds. So a data feed is any source of data in NFDI for Culture that we want to integrate into the Culture Knowledge Graph. It's also, by the way, a schema class, which will become meaningful in a minute. Then we wanted to provide an ATL pipeline that's as freely configurable as possible. So that would allow you as a technical user to use any kind of tool and script with it, because depending on your use case and the repository. And it's a combination of harvesting and publication of the data. So as you can see in that next little Muppet on the left hand, we provide several open source triple store solutions with the Cultural Knowledge Graph Kitchen, Oxograph Virtuoso, and GraphDB, to name 3, which can be deployed with 0 downtime after harvesting of the data. And by the way, on the next slides, you will find some QR codes that you can, if you wish, just catch with your smartphone, and you will be brought to the different GitHub or GitLab repositories where you will find the code of everything we speak today. So just a little harvesting example. So the kitchen is a command line tool that can be used standalone. And so this little animation here shows you that with a single command, you can consume data feeds. And the interesting part is that we store the data feeds and the metadata of what gets to be harvested in our knowledge graph. So in a way, it's a self-description of what we harvest. I'll come to that in a minute. And next, the kitchen goes on and harvests a particular feed. Everything in NFT for Culture gets a particular IRI, and that's a so-called E number. In this case, it's E5307, and that's the identifier for the Culture Information Portal itself. So, and what we conceived as a backbone of that extract, transform, load system is that once we are dealing with knowledge graphs anyway, why not make it an RDF-based system and describe any step that we do within this ETL system with RDF itself? And this is why we've introduced RDF-based so-called action files. And as you can see on the left-hand side, they are schema-based. So schema provides a very nice vocabulary with which you can describe actions on something. In this case, you see there's some metadata, and then you see some actions that we can carry out. And in this case, it's actions on a data feed. So here we describe a consume action with a particular action status. Forced means that's always harvested regardless of what. And we can also acquire some metadata about any kind of process that we have in this kitchen ETL pipeline. So in this case, it's the start time and the end time when a harvesting run on this particular data feed was last started and when it was last ended. And then within schema, you can describe that potential action in more detail. And we have 2 more components in here in our action files. So for one, we can describe a tool or several tools that we wish to take for working and consuming that data. So in this particular case, you can see that we have defined a tool that's called Hydra Scraper. I will show you that in a minute. So it's a particular scraping tool that we use for this, this feed. And we also have a GitHub URL. And for instance, when the kitchen ETL pipeline runs for the first time, it clones the tool and uses it on the steps that are defined in that action file. And the steps are the next and final and most important thing of that approach. A step means any kind of thing or process that you do with the data. For instance, in step 1, you see the Hydra Scraper that we have defined as a tool that we would like to use is applied on the consuming process with a particular command. Python command in this case could be anything else. And it will be executed as first step in the ETL pipeline. And the next steps are several so-called kitchen helper tools. There are several. You will find them in the documentation. You will find the documentation if you use the QR code on the right-hand side. So in this case, in a second step, after we have harvested or scraped the data for that particular feed, we fetch it to a particular location on disk, and there we process it and, for instance, transform it from a TTL file to an ntriples file. So this should give you an impression of how you can describe your data feed. And since this is all RDF, we store it in the knowledge graph. And this serves us for the purpose that we, at the same time, while we are working on the data, we always have a transparent and retrievable self-documentation of how we ingested a particular kind of data into the knowledge graph. So to give you a visual impression of what was just explained, on the lower hand of this slide, you see the 5 steps, it's 6 steps that are provided by the Culture Kitchen ETL pipeline. And it starts with harvesting runs. So first, data is stored in repositories. And the first step in a kitchen is to harvest that data. And it uses information from the portal and the knowledge graph. Then you would clean the data. And another important step in that whole process is that the whole state a kitchen run has done is also tracked with Git. So it's version control so that we always know what happened in what state at what particular time. Data can then be prepared and indexed. And then at the end of a harvesting run for all registered data feeds, we build up a new Sparkle endpoint, and of course, we deploy a new triple store for this. And we also can generate some statistics on what was done in a kitchen run, and that is going to be published to a public dashboard. I'll just give you a little overview over 1 or 2 tools that are already mentioned in that whole process. One is quite interesting, maybe also for your projects. While we developed the kitchen, we also developed a tool called Hydra Scraper. And Hydra is a community standardization initiative by the W3C. Community Hydra is a sort of semantic way of describing APIs, and the Hydra Scraper uses that W3C community standard and helps you very easily collecting data that is in that particular format. Where do we use it? Harald has already mentioned this. Since we have many data providers that don't give us a particular or dedicated API or Sparkle endpoint, we have developed the culture graph interchange format, and that is based on that Hydra W3C standard. And the culture graph interchange format can be directly embedded in the front end of websites, because we realize that very many of our data providers might not develop a particular API, but they always have control over their front ends. And once they provide data in an embedded form, in a structured form, we can easily harvest this with the Culture Kitchen and the Hydra Scraper that comes with it. Yes, and this is just a brief look. Maybe we can speak in more detail about this later. So for instance, here you have an example from medieval stained glass, the Corpus Vitriarum Medievi Germany, and the corpus provides structured data embedded in their website, and we directly fetch it from there for integration in the knowledge graph. It has another additional benefit to do it like this, because this can also be read by all the large search engines, and it's really good for search engine optimization to have the data embedded in a particular website in structured form. So while we are integrating it in the knowledge graph, we also give some benefit for the particular data provider and their websites themselves. For the publication and delivery of the integrated data, our pipeline can integrate a multitude of open source triple stores. I've already mentioned that so far we've integrated Virtuoso, GraphDB, and Oxygraph. We are planning to integrate some more in the future. And for each of those triple stores that come together with the kitchen, we provide the most efficient bulk loading mechanisms per triple store. That's of course different per triple store. And for us, a very important principle was that we always wanted to have 0 downtime deployments, since the culture knowledge graph at the moment is built every night. Of course, that might vary in the future, but we never want to have downtimes while we build it, because that would really impede querying on the knowledge graph. Yes. For conclusion, some final benchmarks. So at the moment, an ETL run with with those 3 triple stores clearly shows that virtuoso for us at the moment, as you can see, regarding the ingest time, also the startup time, and especially performance in count queries, excels over Oxygraph and GraphDB. We use for particular scenarios internally, we use them all, but our public facing triple store at the moment is virtuoso. So summary, before I hand over to Harald, with the Cultural Knowledge Graph Kitchen, we provide several reusable components, the ATL pipeline, the harvesters, of course, regarding the culture portal, the front end, and also a Sparkle endpoint, and finally, an ontology about which Harald will now speak.
Thank you, Torsten. Okay, so let's talk now about the NFDI core ontology and its extensions. So keeping in mind that we are talking about a knowledge graph-based research data management approach, so we have here the knowledge graph, and of course, this knowledge graph has to obey a specific schema. So this is then the underlying ontology. And since we have already found out that, NFDI for Culture is not the only consortium, and many consortia share similar pain points and problems, we went on and developed something like a core ontology, the NFDI core ontology, which can be used then to represent information from several consortia. And for that, there are so-called domain-specific module extensions. That means for the culture domain, so for all of the disciplines that are represented in culture, like, for example, musicology, like, for example, performing arts and others, there are domain-specific extensions to exactly that core ontology to be used for. So the core ontology, we were following a modular approach simply to get a better overview and to make it also easily adaptable by different disciplines, and not only, let's say, domain-specific information, also sometimes function-specific or subject-specific extensions can also be defined there. And as you see here, we have already included a few module extensions that already exist. So of course, there is a culture extension, there is a extension for NFDI Mathwerk, and another one for NFDI for data science, and NFDI for memory is already in the making, so also to support an NFDI for memory knowledge graph. So where does this NFDI core ontology come from? So what we did was, in the beginning of writing the proposal, we had lots of use cases and problem statements of things that we collected, of problems that were inherent in many of the consortia. So we started with 4. We started with the NFDI for Culture, Data Science, Mathwerk, and then in the last round, Memory. And what we did there, we collected there all of these use cases that have been defined. And from these use cases, we developed a set of competency questions. Overall, we extracted 98 competency questions. So you can see them here then also on our webpage. And there are all of the competency questions and the the corresponding Sparkle queries with which you can then query the underlying knowledge graph for exactly the results that were asked for in that competency question. So it not only came from NFDI for Culture, so the basis of the core ontology, as you see here, comes from several consortia. Therefore, also we have boiled down together this core to things which might be interesting across different domains. Across different domains is a good key point, or let's say subject, because we wanted, of course, to enable interoperability, especially also with other existing solutions. And this meant that we had to base our ontology on a foundational ontology that is in wide use. And we decided to go for the BFO, so which is the basic formal ontology. This is a foundational ontology, which is heavily used, for example, in the natural sciences and engineering, but also in the biomedical domain. And there you have a conceptual clarity, which means the overarching generic classes are very well defined, and also they are discriminated and differentiated from each other. Nevertheless, all other ontologies that are also based on BFO, there you have a rather simple interoperability across many different disciplines. This comes, of course, at a price, because in the end, it includes some difficulties, especially if it comes to complexity in expressing simple things. And for that, we have developed a set of rules. They are implemented in Swirl, and they simply then translate a longer chain of, let's say, connections between entities into a single, rather simple property. So this is then a Swirl extension of that ontology. To get a better idea, let's have a look at the NFDI core ontology. You see here at the top the BFO layer, where you have generic concepts like, for example, independent continuance or information content entities or occurrence. And here is the NFDI core ontology. And of course, the main things we are talking about in NFDI core are resources. So usually digital information artifacts that come from the different consortia. There are independent continuants that exist autonomously, like, for example, we might have different kind of agents, we might have collections, we might have places, locations, and stuff like that. And on the other hand, we also might have kind of processes. So these are then here occurrence, processes and events, like an NFDI core project or an NFDI core event. And our modular extension for culture could look like the following way. For example, we want to include also musical compositions, which are kind of resources, but are specific kind of resources. And they are, for example, aggregated in so-called as a data feed element. And the data feed element is usually related to some kind of agent. So some persons are responsible for that. And this is an element then from an NFDI core resource. For Mathwerk, different things then have to be represented. For example, experimental workflows will be represented, which is then defined as a subclass of an NFDI core resource. And this workflow might use a specific instrument here, a laboratory instrument. In data science, on the other hand, for example, we are also representing events, like, for example, here an NFDI for data science conference. And there are resources like, for example, the proceedings of exactly these conferences. So you have a conference of proceedings which are associated with a conference. Conference usually is a subclass here of event, and it's co-located with, let's say, some other event like an hackathon, for example. So here you can see how in these three different NFDIs, how exactly these modular extensions might look like and how they are connected to the NFDI core ontology. And besides these three that we have already introduced, of course, there are also plans to connect it further, for example, with for memory, with MADI, and also with NFDI for objects. What have we achieved so far with the NFDI core ontology? So we have improved the interoperability of our resources with enhanced expressiveness and precision. Another thing is also we can make use of reasoning capabilities, especially then in the Sparkle queries on the triple store endpoints. But as I already told you, we have to pay a price. This comes also with a high complexity within the ontology that had to be translated via shortcuts and these swirl rules into simple and plain properties, which then enable us to efficiently really also query those ontologies. The entire NFDI for culture ontology module looks like that. So we have defined here a number of additional classes related to the NFDI for culture specific resources, like, for example, lyrics, musical work, creative work, and so on. They come with a bunch of new properties, for example, associated specific kind of images, icon class codes, or stuff like that. Then we have data type properties, for example, like literals that express a location or a person. So in these cases, when from the original resources, we don't receive entities, we only get a string then in the end. And we have annotation properties where we can annotate creator's title, abstracts, and so on. Just to give you an impression what kind of data in the various forms we are including. For example, when we get here data from a Sparkle endpoint, this is here from the linked stage graph, we are not simply harvesting the original properties that are represented there. So what we are harvesting is we are translating related organizations, related documents, and related persons to a given subject. So here, for example, subject is a theatrical piece with the name Was ihr wollt, 12th Night. from William Shakespeare. And these related persons are in the original data source, for example, the actors or the creators. But in the index, it's just the related person, simply to be able with the index that we can make a cross connection over all of the resources that are there, and without having to have, let's say, a rather complex and complicated ontology underneath. For example, if we have here data that is represented in OAI PMH Lido, here, for example, from the Bibliotheca Hertziana, we have a subject that is also here, which is Grabmonument des Kardinal Alano Coitivi. So this is also related to a publisher, which is an organization. It's related to other kind of documents, to persons, and also there is a source file, which is also another kind of document. So that can also easily mapped to the ontology, as you've seen here. This here is the CGIF mapping. So we had already this corpus vitriarum with these stained medieval glass windows. And also here you can extract organizations, items, documents, and locations. And the most complex thing so far we have adapted are Wikibase-based knowledge graphs. This is an example from FactGrid, where you also see that here are lots of events, persons, locations, and documents that can be extracted and connected within our index. If it comes to interconnect the stuff, then on the entity, on the instance level, of course, as we already said, authority data is there to connect everything. So we try, of course, to annotate all of the entities with their GND identifier if possible, or with Wikidata identifiers, or we have already mentioned icon class for iconographic descriptions. So far, we have integrated, as you see here, roughly 8 million items and have produced in that knowledge graph around 70 million triples. And this is only the beginning because, as you have heard, we think that there are almost 100 million resources to be included. So now, what lies ahead? Of course, we are trying somehow to cooperate with other disciplines. So we have on the one hand side this memorandum of understanding group of all of the humanities-focused consortia consisting out of NFDI for Culture, Text Plus, NFDI for Memory, and NFDI for Objects, where we, of course, offer our infrastructure. And also, for example, with Text Plus, we are about to integrate first resources from Text Plus also in the NFDI for Culture knowledge graph. And of course, we try also to spread the NFDI for core ontology and also further refine this ontology, because we realized with each new consortium that we are adapting to that ontology, there are further requirements or things that we haven't thought of so far and that also have to be changed. So this is a living process, and the ontologies in the end, they become community maintained. Next steps, of course, we want to further populate our research data graph, of course, in federation with other portals and also with other consortia. And of course, we want to support more community standards now also in this transformation process. And in the end, the latest thing that we have developed is the so-called NFDI for Culture data search. This enables then also a user-friendly exploration of this knowledge graph without the necessity to be an expert in Sparkle and all of these other technologies that we have mentioned now. But this is already in the making. Right now, as you might see here, Torsten and I, we are sitting here in a hotel room in Bonn, waiting for the defense of NFDI for Culture Phase 2, which takes place tomorrow, a few kilometers ahead at DFG. So please keep your fingers crossed for us that we can make it then also for the second round. And now, of course, thank you very much for your attention. This is the entire team I have to thank for the development of all you have seen here. And now, of course, we are ready for your questions.
So thank you very much for this talk. With that, we say goodbye on YouTube and stop our live stream. So our next NFDI episode is on 16 December, and we will have a talk about standardization of